There's something profoundly moving about standing on an airport tarmac as a massive wide-body jet thunders overhead, its shadow eclipsing everything beneath it like a great mechanical cloud. In that moment, you're witnessing one of humanity's most audacious achievements, the conquest of gravity itself. These aren't just machines, they're flying cities, technological cathedrals that defy every instinct nature gave us about what should and shouldn't be able to leave the ground. The story of aviation's largest passenger aircraft is a story of ambition without limits, of engineers who looked at the laws of physics not as barriers but as puzzles waiting to be solved. From the earliest dreams of flight to today's ultra-efficient giants, capable of carrying more than 500 souls across entire oceans without refueling, each aircraft on this list represents a pivotal moment in our species' relationship with the sky. What makes an aircraft truly big is more nuanced than you might think. Yes, physical dimensions matter tremendously. Wingspan, fuselage length, and height all contribute to an aircraft's presence and capability. But size also manifests in passenger capacity, in cargo volume, in maximum takeoff weight, and in the sheer operational complexity required to get these behemoths airborne. So buckle your seatbelt, stow your tray table, and prepare for departure as we count down the 20 biggest passenger planes ever to grace our skies. Number 20. Boeing 777-200. Our journey begins with an aircraft that redefined what long-haul travel could be. When the Boeing 777-200 entered service in 1995, it marked a turning point in aviation history, proving that twin-engine aircraft could rival the giants of the sky. Stretching roughly 209 feet in length, with a wingspan approaching 200 feet, this wide-body titan instantly became the largest twin jet in the world, setting a new benchmark for efficiency and capability. In a typical three-class layout, the 777-200 carries between 300 and 320 passengers, though high-density configurations can push that number beyond 400. But its true revolution was invisible to passengers. It was the first commercial aircraft designed entirely with computer-aided design, allowing engineers to build and test the airplane virtually before a single part was manufactured. This digital design revolution eliminated countless engineering errors and transformed how modern aircraft are built. Powered by engines delivering up to 98,000 pounds of thrust, the 777-200 cruises at Mach 0.984 and can fly roughly 5,200 nautical miles. With a maximum takeoff weight exceeding 540,000 pounds, it was a heavyweight that ushered in a new era of twin-engine dominance. Number 19. Boeing 777-200ER. The Boeing 777-200ER took everything revolutionary about the original 777 and pushed it even further. Externally, it looks almost identical, but beneath the skin lies a fundamentally more capable aircraft. Reinforced structures and expanded fuel capacity allowed it to achieve an astonishing range of more than 7,300 nautical miles, enabling nonstop routes that once seemed impossible. This aircraft typically seats around 300 to 314 passengers, though airlines can configure it for far more. With a maximum takeoff weight exceeding 630,000 pounds, it is nearly 90,000 pounds heavier than the original version, translating directly into greater range and payload flexibility. Priced at nearly $300 million, the 777-200ER became a backbone of intercontinental aviation, flying 16-hour marathon routes with remarkable efficiency and reliability, forever changing how airlines connected the world. Number 18. Airbus A330-200. When the Airbus A330-200 arrived in 1998, it represented Europe's answer to the growing demand for efficient long-haul aircraft. Measuring just over 208 feet in length with a wingspan of nearly 200 feet, it was slightly smaller than its American rivals, but engineered with exceptional efficiency. The A330-200 typically carries between 240 and 300 passengers and boasts a range of over 7,000 nautical miles, making it ideal for transoceanic and intercontinental routes. With a maximum takeoff weight of around 530,000 pounds, and engines producing up to 72,000 pounds of thrust, it cruises comfortably at Mach 0.82. With a list price near $240 million, it offered airlines a cost-effective alternative to larger aircraft. Its shared cockpit and systems philosophy allowed pilots to transition easily between Airbus models, reducing training costs and increasing fleet flexibility. Number 17. Airbus A330-300. The Airbus A330-300 stretched the A330 platform into a higher-capacity aircraft designed for busy long-haul routes. At roughly 209 feet long with the same wingspan as the 200, it maximizes cabin volume while maintaining efficient aerodynamics. This variant typically carries between 290 and over 400 passengers depending on configuration and can fly around 5,600 nautical miles. With a maximum takeoff weight exceeding 514,000 pounds and engines delivering up to 72,000 pounds of thrust, it cruises at Mach 0.82 with a spacious cabin nearly 18 feet wide. Costing around $260 million, the A330-300 became one of the most popular wide-body aircraft in history, prized for its reliability, passenger comfort, and airline-friendly economics. Number 16. Boeing 787-10 Dreamliner. The Boeing 787-10 Dreamliner represents the cutting edge of modern aircraft design. At approximately 224 feet long with a wingspan near 200 feet, it is the largest member of the Dreamliner family and one of the most advanced passenger jets ever built. Typically carrying between 330 and 350 passengers, the 787-10 is built primarily from carbon fiber composites, making it dramatically lighter and more fuel efficient than traditional aluminum aircraft. Its maximum takeoff weight exceeds 560,000 pounds, and its engines produce up to 78,000 pounds of thrust, propelling it at Mach 0.85 with a range of more than 6,400 nautical miles. With a list price approaching $338 million, the 787-10 also transformed the passenger experience. Higher cabin humidity, lower cabin altitude, larger windows, quieter engines, and advanced LED lighting create one of the most comfortable long-haul environments ever created. Real-time health monitoring systems constantly report aircraft status to ground crews, allowing predictive maintenance before problems arise. Number 15. Boeing 777-300. The Boeing 777-300 stretched the proven 777 platform to remarkable proportions. At 242 feet in length, it was the world's longest airliner when entering service in 1998. With a wingspan identical to the 777-300 at 199 feet 8 inches, it demonstrates how airframe stretch programs create essentially new aircraft while maintaining commonality. This long-haul giant typically carries between 365 and 396 passengers in 3-class configurations, with dense layouts accommodating over 500 passengers. The internal volume offers tremendous cabin configuration flexibility. Maximum takeoff weight reaches 660,000 pounds, making it one of the heaviest twin-engine aircraft at introduction. Powered by turbofan engines producing between 92,000 and 98,000 pounds of thrust each, the 777-300 cruises at Mach 0.84 with a range of approximately 5,950 nautical miles. It excels on high-capacity routes like Tokyo to Los Angeles, Singapore to London, or Dubai to New York. The list price approached $320 million. Despite being over 30 feet longer than the 777-300, it maintains nearly identical handling characteristics and operates from the same runways. The tail was strengthened and slightly enlarged for directional stability, but pilots needed minimal additional training. Landing gear features 14 wheels total. The fuselage is so long it requires special maneuvering procedures at some airports to prevent tail strikes during takeoff rotation, with pilots carefully monitoring pitch angle. Number 14. Boeing 777-300. The 777-300ER represents perhaps the most successful wide-body airliner of the 21st century. maintaining the same 242-foot length and 199-foot wingspan as the standard 777-300. The variant packs an additional fuel capacity for truly global reach. Configured for between 365 and 396 passengers, the 777-300 can fly them an astounding 7,370 nautical miles. This extraordinary range opened routes like Los Angeles to Melbourne or Dallas to Sydney. Maximum takeoff weight swells to 775,000 pounds. Powered by engines delivering between 110,000 and 115,000 pounds of thrust, it cruises at Mach 0.84. With a list price of approximately $375 million, airlines embraced it enthusiastically. The aircraft can fly for over 18 hours continuously, enabling the longest scheduled passenger flights in history. Number 13. Boeing 747. The Boeing 747 needs no introduction. When the 747-100 entered service in 1970, it was a radical gamble that nearly bankrupted Boeing, but paid off spectacularly. The early variants measured 231 feet in length, with a wingspan of 195 feet 8 inches. The distinctive hump housing the cockpit and upper deck became the 747's signature. These variants typically carried between 416 and 524 passengers. Maximum takeoff weight ranged from 733,000 to 833,000 pounds on later variants. Powered by 4 engines producing between 43,000 and 56,000 pounds of thrust each, early 747s cruised at Mach 0.84 with ranges from 4,600 to over 7,000 nautical miles. List prices ranged from $24 million for early 747s 100s to over $150 million for late 747s 300s. The 747 democratized long-haul air travel, making international flights accessible to the middle class for the first time. Number 12. Airbus A340-300. The Airbus A340-300 brought European engineering to ultra-long-haul operations. Measuring 208 feet in length, with a wingspan of 197 feet 10 inches, the A340-300's 4-engine configuration provided redundancy valued for remote ocean operations. Accommodating between 295 and 340 passengers, maximum takeoff weight reaches 608,000 pounds. Powered by 4 engines producing approximately 34,000 pounds of thrust each, it cruises at Mach 0.82 with a range of 7,400 nautical miles. The list price approached $238 million. The 4 smaller engines produced less cabin noise than 2 larger engines, and advanced fly-by-wire controls gave exceptional handling. The A340-300 pioneered cockpit commonality across Airbus types. It could fly Los Angeles to Melbourne non-stop, showcasing extraordinary range capabilities. Number 11. Boeing 747-400. The 747-400 represents the pinnacle of classic jumbo jet evolution. Introduced in 1989, it measures 231 feet 10 inches in length, with a wingspan of 211 feet 5 inches, featuring distinctive winglets. Configured for between 416 and 568 passengers, the 747-400 could fly 7,660 nautical miles fully loaded. Maximum takeoff weight reaches 875,000 pounds. Powered by 4 engines producing between 56,000 and 63,000 pounds of thrust each, it cruises at Mach 0.85. The list price approached $266 million. The revolutionary 2-person glass cockpit eliminated the flight engineer position. The stretched upper deck allowed more premium passengers, and the aircraft set multiple distance records, including London to Sydney, covering over 11,000 miles. Number 10. Airbus A340-600. The Airbus A340-600 holds a special place as the longest commercial airliner ever built. At 247 feet 3 inches in length, with a wingspan of 208 feet 2 inches, this aircraft challenged engineering limits. Configured for between 375 and 440 passengers, maximum takeoff weight reaches 804,000 pounds. Powered by 4 Rolls-Royce Trent, 500 engines producing 56,000 pounds of thrust each. It cruises at Mach 0.83 with a range of 7,900 nautical miles. The list price approached $275 million. The extreme length created significant challenges, requiring fuselage strengthening and special landing gear with retractable tail skid protection. Despite its length, the A340-600 could maneuver at airports designed for smaller aircraft with careful planning. Number 9. Boeing 747-8. Intercontinental. The 747-8 Intercontinental represents the final evolution of the Queen of the Skies. At 250 feet 2 inches in length, with a wingspan of 224 feet 7 inches featuring raked wingtips, this is Boeing's longest aircraft ever. Configured for between 467 and 581 passengers, maximum takeoff weight reaches 987,000 pounds. Powered by 4 General Electric GNX engines producing 66,000 pounds of thrust each, it cruises at Mach 0.86 with a range of 8,000 nautical miles. The list price approached $418 million. The aircraft incorporates technology from the 787 Dreamliner program, achieving 15% better fuel consumption than the 747-400. Boeing ended 747 production in 2023 after over 50 years, making it one of aviation's longest-running programs. Number 8. Airbus A350-1000. The A350-1000 represents cutting-edge wide-body design. At 242 feet 1 inch in length, with a wingspan of 212 feet 5 inches, over 50% of the airframe uses composite materials. Configured for between 369 and 412 passengers, maximum takeoff weight reaches 699,000 pounds. Powered by 2 Rolls-Royce Trent XWB engines, producing 97,000 pounds of thrust each, it cruises at Mach 0.85 with a range of 8,700 nautical miles. The list price approaches $366 million. The cabin features the widest economy seats of any twin-aisle aircraft and the largest windows with electrochromic dimming. Cabin altitude is maintained at 6,500 feet. The variable camber wing optimizes efficiency throughout flight, and the aircraft can fly Singapore to New York nonstop. Number 7. Boeing 777X8. The 777X8 showcases technology defining aviation's future. At 229 feet in length with a wingspan of 235 feet 5 inches, it features the longest wingspan of any commercial airliner, made possible by revolutionary folding wingtips. Configured for between 350 and 375 passengers, maximum takeoff weight reaches 694,000 pounds. Powered by 2 General Electric GE9X engines producing 110,000 pounds of thrust each, it cruises at Mach 0.85 with a projected range of 8,730 nautical miles. The list price is estimated at $425 million. The GE9X engines feature 134-inch fan diameters and utilize 3D printed components. The folding wingtips reduce wingspan to 212 feet after landing, allowing use of standard gates. Number 6. Boeing 777X9. The 777X9 takes everything impressive about the 777X8 and scales up. At 251 feet 9 inches in length, with the same 235-foot wingspan and folding wingtips, it's the longest twin-engine airliner ever conceived. Configured for between 426 and 461 passengers, with high-density layouts exceeding 550, maximum takeoff weight reaches 775,000 pounds. Powered by the same GE9X engines producing 110,000 pounds of thrust, it cruises at Mach 0.85 with a range of 7,285 nautical miles. The list price is estimated at $442 million. Despite its enormous size, it's projected to burn 15% less fuel per passenger than the 777-300ER. The cabin is the widest of any Boeing commercial aircraft at 232 inches. Number 5. Airbus A340-500. The Airbus A340-500 was designed with a singular purpose: to fly farther than any airliner before it, pushing the boundaries of what commercial aviation could achieve. At 222 feet 9 inches in length, with a wingspan of 208 feet 2 inches, this aircraft deliberately sacrificed passenger capacity for unprecedented range capability, creating a specialized machine for the world's longest routes. Configured typically for between 270 and 315 passengers in premium configurations that emphasized comfort over density, the A340-500's maximum takeoff weight reaches an impressive 820,000 pounds. This massive weight capacity was dedicated primarily to fuel, allowing the aircraft to carry enough to cross entire oceans and continents without refueling. Powered by four Rolls-Royce Trent 553 engines producing 53,000 pounds of thrust each, the A340-500 cruises at Mach 0.83 with an extraordinary range of 9,000 nautical miles, a figure that seemed almost impossible when the aircraft was introduced. The list price approached $263 million, reflecting its specialized mission and limited production run. In 2004, Singapore Airlines used this aircraft to launch the world's longest scheduled passenger flight, connecting Singapore and New York nonstop, covering over 9,000 nautical miles in approximately 18 hours of continuous flight. This route showcased the aircraft's capabilities and demonstrated that distance was no longer a barrier to air travel. Number 4. Airbus A380-800. The Airbus A380-800 stands as one of aviation's most audacious achievements, an aircraft so large it required airports worldwide to modify their infrastructure. At 239 feet 6 inches in length, with a wingspan of 261 feet 8 inches, this full double-decker aircraft creates interior volume that defies comprehension, offering airlines unprecedented space for passenger amenities and comfort. Configured typically for between 515 and 570 passengers in three-class layouts, with theoretical all-economy configurations exceeding 850 passengers, the A380's maximum takeoff weight reaches 1,235,000 pounds, making it the heaviest commercial airliner ever built. This incredible weight required revolutionary engineering solutions throughout the aircraft's design. Powered by four massive engines producing between 70,000 and 76,000 pounds of thrust each, depending on whether airlines chose Rolls-Royce Trent 900 or Engine Alliance GP7200 power plants, the A380 cruises at Mach 0.85 with a range of 8,200 nautical miles. The list price approached $446 million, making it one of the most expensive commercial aircraft ever sold. The wing area exceeds 9,000 square feet, providing the massive lift needed to get over 1,000,000 pounds airborne. The landing gear features 22 wheels distributed across 5 assemblies to spread the enormous weight and prevent runway damage. Despite its massive size, the A380 is remarkably quiet, both inside the cabin and for communities near airports. Airbus ended production in 2021 after building just over 250 aircraft, far fewer than the break-even point. Number 3. Boeing 747-8F Freighter. The Boeing 747-8F represents the ultimate evolution of the 747 platform, optimized entirely for cargo operations rather than passengers. At 250 feet 2 inches in length with a wingspan of 224 feet 7 inches, it's externally similar to the passenger variant but features systems and structures optimized for freight movements around the globe. The main cargo deck accommodates 39 pallets measuring 88 by 125 inches, while the lower deck holds an additional 11 pallets. Total cargo volume reaches 30,700 cubic feet, with a maximum payload capacity of 308,000 pounds, allowing it to carry massive amounts of freight. Maximum takeoff weight reaches 987,000 pounds, identical to the passenger 747-8 Intercontinental. The list price approached $418 million. Range with maximum payload reaches 4,390 nautical miles, sufficient to connect major cargo hubs across continents. The nose section opens upward on massive hinges for loading, and the aircraft has carried everything from satellites and industrial machinery to livestock and humanitarian supplies. Number 2. Antonov. and 124 Ruslan. The Soviet era, Antonov, and 124 Ruslan found unexpected commercial success after the Cold War ended, becoming the go-to aircraft for outsized cargo that simply won't fit anywhere else. At 226 feet 8 inches in length, with a wingspan of 240 feet 5 inches, this strategic airlifter was designed for military purposes, but proved invaluable for moving oversized industrial cargo. The cargo deck measures an astounding 120 feet long, 21 feet wide, and 14 feet 4 inches high, creating a cavern capable of swallowing vehicles, industrial equipment, and machinery whole. Maximum payload reaches 330,000 pounds over a range of 2,950 nautical miles. Maximum takeoff weight peaks at 892,000 pounds, requiring 4 massive ZA MKB Progress D-18T engines. The list price was approximately $100 million during production. The nose opens upward while the rear cargo ramp deploys downward for drive-through loading of vehicles. An overhead crane system rated for 30 tons assists with loading, and the aircraft regularly carries cargo that physically cannot fit in any other flying machine. Number 1. Stratolaunch. At our countdown's pinnacle stands the Stratolaunch, the largest aircraft ever built by Wingspan, representing humanity's most ambitious aircraft design. At 238 feet in length, its wingspan extends to an incomprehensible 385 feet. Wider than a football field is long, making it the widest aircraft in history by a substantial margin. The unique twin fuselage configuration stands 50 feet tall, creating a distinctive silhouette unlike any other aircraft. Maximum takeoff weight reaches 1,300,000 pounds, over 500,000 kilograms. Powered by 6 Pratt & Whitney PW4056 engines producing 56,000 pounds of thrust each, the same engines used on Boeing 747-400s. It carries payloads up to 550,000 pounds suspended from the center wing section. Development cost several $100 million. The twin fuselage design required solving unprecedented aerodynamic and structural challenges never before encountered. The landing gear features 28 wheels spread across multiple assemblies. First flight came in April 2019, demonstrating that even the most audacious designs can become reality with sufficient engineering determination. The wingspan flexes over 30 feet during flight, testament to the composite structure's remarkable strength and flexibility. Our journey through aviation's giants reveals more than size progression. It shows human ambition evolution. Each aircraft represents countless engineering hours, billions in development, and thousands of brilliant minds collaborating. These machines transcend transportation, standing as monuments to ingenuity, proving we can overcome gravity and make the impossible routine. We've seen how engineering philosophies differ between manufacturers, how 4-engine designs yielded to efficient twin-engine giants, how composites replaced aluminum, and how computers transformed design and operation. Development costs now exceed $10 billion, requiring hundreds of sales to break even. The largest aircraft struggled commercially despite technical excellence, while machines like the 777-300ER succeeded through compelling size, range, and efficiency combinations. Looking forward, environmental pressures drive more efficient engines, alternative fuels, and revolutionary propulsion. Composites continue evolving, offering weight savings, improving performance. Advanced manufacturing and digital design reduce costs and time, yet fundamentals remain unchanged. Larger aircraft face airport challenges, requiring longer runways and specialized equipment. Very large aircraft economics work only on the busiest routes. Passenger preferences increasingly favor frequency over size. These aircraft connected our world impossibly just decades ago, making intercontinental travel accessible to billions, enabling global commerce and shrinking our planet. Whether carrying business travelers, moving industrial equipment, or launching satellites, these giants represent aviation's pinnacle. Each embodies millennia-old flight dreams realized through engineering excellence. They remind us that when we imagine the impossible and commit to reality, limits virtually disappear. Next time you watch one thunder skyward carrying hundreds to distant destinations, appreciate not just the machine, but everything it represents: human ingenuity, collaborative achievement, and our endless drive pushing boundaries. These are more than aircraft. They're flying testaments to human potential, inspiring new generations for decades to come.